Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 9 on categorical data. So throughout this unit, we've been working with numerical data, right? We go out and we measure the height of something or the temperature of something or the gas mileage of something. In today's lesson and then in the next lesson, we're going to be working with what's known as categorical data. So let's talk a little bit about that, right? We have now worked extensively with quantitative or numerical data for two variables. We can also work with categorical data, which just simply shows us how many things surveyed fall into a given category. And you've definitely worked with categorical data in various courses. You certainly should have worked with it in both Math 6 and Math 7, and hopefully a little bit in Math 8. So let's take a look at exercise number 1. Daniela is trying to determine if there is any association between how students get to school and whether or not the students buy lunch or bring lunch from home. She does a survey and partially fills out the following frequency table. All right, great. So again, these things are known as frequency tables. They literally are saying, okay, we've got all these people that we surveyed, right? And then we broke them into these various categories. Now I want to make sure that you can read the frequency table. So let's take a look at letter A. How many people rode the bus and bring their lunch? All right, so, that's simple enough. We want to figure out the people who rode the bus and bring their lunch. That's 12 people, right? So those are the people that fall into both categories, and that's just 12. Simple, easy math. Let's take a look at letter B. How many people buy their lunch? Well, here we have to do a little bit more work because there are 7 people who walk to school and buy their lunch, and there's 22 people who take the bus and buy their lunch. So in total, there are 29 people who buy their lunch, right? 7 plus 22, there's going to be 29 people that buy their lunch. All right, good enough. Now, letter B, which really should say letter C, fill in the table by filling in the missing total blanks. Let's put a little letter C there. That's going to be a bit better. All right, so sometimes frequency tables have totals for both the columns, those are the vertical things, and for the rows, those are the horizontal things, and sometimes they don't. Almost always it is helpful to have those totals. You don't always need them, but often you do. Now we already figured out one total, right? When we did the 7 plus the 22, that gave us 29. And if we do 9 plus 12, that gives us, that gives us 21. Now keep in mind what those two totals tell us, right? The 29 is all the people who buy their lunch, and the 21 is all the people who bring their lunch. On the other hand, we can also sum across the rows, right? And so 7 plus 9, that's easy enough, 16. That means that 16 people walk to school. 22 plus 12 is 34. 34 people rode the bus. Now, to get our grand total down here, we can either add these two or we can add these two, and they've got to be the same. And in fact, if we add either one of them, what we'll find is that a grand total of 50 people, right? 50 people were in this survey, right? That's all that number represents. Now, by the way, for much of what we're going to be doing today, we're going to need a very basic scientific calculator. Even the calculator on your phone will do. You don't need a graphing calculator. So we're actually going to be using just a simple Texas Instruments scientific calculator to do many of our calculations. But let's keep moving on. Now, the next thing we want to talk about are what are called relative frequency tables. We often want to think about frequencies in each category as a proportion or fraction of the total. To do this, we create what's known as a relative frequency table by simply dividing each entry by the overall total. So this is important, right? In math, a frequency is a count of how many things fall into a category, right? That's a frequency. A relative frequency is a proportion or a fraction of the total that fall in each category. So let's take a look at that in exercise number 2. Daniela would like a relative frequency table for her data. Fill in the table below with all relative frequencies by dividing each entry in the original table by the total. You will not need to round any of your relative frequencies. Okay, so what I'm going to do is in each case, I'm going to take every single number in this table and I'm going to divide it by 50. So literally, I'm going to take 7 and divide it by 50. And of course, I can do that on my calculator, and I want this as a decimal. I'll just do 7 divided by 50. That's 0.14. Okay. Then I want 22 divided by 50. Because 50 is such a nice denominator, we're not going to have to round whatsoever, and I get 0.44. I'm going to do 29 divided by 50. And that's going to give me 0.58. And then I'm going to do 9 divided by 50. Whoops, that's not what I want. Let me just clear all this out. 9 divided by 50. Oh, that is just not working well. 9 divided by 50 gives me 0.18. 12 divided by 50 would be 0.24. 21 divided by 50 would be 0.42. You get the idea. And let's do 16 divided by 50 would be 0.32. 34 divided by 50 would be 0.64. And 50 divided by 50 would be 1, but I'm going to put 1.00 for the time being. Right? Obviously, 50 divided by 50 is going to be equal to 1. Any number divided by itself is equal to 1. But since I'm writing every one of these down accurate to 2 decimal places, all right, which they often are in these tables, I'm going to do the same for that grand total. All right. Now, exercise 3 is very important. Let's take a look at it. Relative frequencies are essentially the decimal version of what common math idea? So, these are my relative frequencies, but how can I really think about them? What are they really? When I take a part and I divide it by a total and I get a decimal, what is that really very similar to? Pause the video now. Well, these are essentially the decimal version of percents, right? 14%, 44%, 58%, 18%, 24%, because what a percent is something out of 100. This is 14 100ths, this is 44 100ths, 58 100ths, 18 100ths, 100 100ths, right? So this is simply the decimal version of a percent, right? And that's key, because what these relative frequencies are really saying is what percent of the total fall into each category. Let's see if we can answer that in exercise number 4. In the survey, what percentage of the students, A, take the bus and bring their lunch? All right, well, it's this simple, right? I look at the bus, I look at the bring their lunch, 0.24, right? That means 24% of all the students, right, rode the bus and bring their lunch. Letter B, what percentage of the students walk to school? All right, well, write down what percentage of the students walk to school. Well, that is all the students who walk to school, and that's 32%. So even though we typically fill relative frequency tables in with decimals, all right, the way that we almost always interpret them is by thinking about percents. 24% of the students, about 1/4 of the students, right, rode the bus and brought their lunch. 32% in total walked. Okay, let's keep going. Now sometimes we are interested in the relative frequencies of a category compared to either a row or column total. So before we were looking at sort of the relative frequencies compared to the overall total. But sometimes we just want to know them compared to a row or column total, and these are known as conditional relative frequencies. So now we have 3 terms. We've got a frequency, which is just a count. 5 people fell in this category, 10 people fell in that category. A relative frequency, which is literally the overall fraction or percent or proportion of, this category that occurred. And then a conditional relative frequency, which is the proportion or fraction of a row or column total that falls in a particular category. That probably is a bit confusing. So let's try to get a sense for it in exercise number 5. Find each of the following conditional relative frequencies. Give as both a decimal to the nearest hundredth and as a percentage. Okay, so let's take a look at this. Letter A person brings their lunch given that they walk. All right, and the real key is this piece of language, given that they walk. A person brings their lunch given that they walk. At that point, I don't care at all about the people riding the bus. I just don't. They're not even part of my consideration, right? I also don't care about people who drive Maseratis, right? I only care about people that walk, right? There are 16 people that walk. That's my denominator, okay? I want to know the conditional relative frequency that the person brings their lunch. So how many people bring their lunch who walk? 9. And so I'm going to do this, 9/16, right? Because again, I only am worried about this total now. And that, of course, I just need my calculator on, right? So let me just clear this out. I'll do 9 divided by 16. And that's going to be 0.56 rounded to the nearest hundredth. Okay, and that is, of course, 56%. And keep in mind, right, all I'm saying is, look, of the people who walk to school, 56% of them bring their lunch. That's it. It's not that hard. We don't even have to get wrapped up in conditional relative frequency or anything like that, right? 56% of people who walk to school bring their lunch. That's it. Now let's take a look at letter B. A person rides the bus given that they bring their lunch. Okay, well, see if you can figure out the conditional relative frequency for this and the percent that goes along with it. All right, again, real key. Given they buy their lunch. As soon as I see that, these are the only people I am worried about. Okay? They're the only one I'm worried about. I don't care about the people that bring their lunch. I don't care about the people that make their lunch while they're there. I don't care about anybody else. Given that they buy their lunch, so that means 29 is my denominator, right? Given that they buy their lunch and a person rides the bus, right? So there it is. 22 out of 29. So we just do 22 divided by 29. Enter. 0.7586, etc., rounded to the nearest hundredth. That's going to be 0.76. And that's 76%. And again, it doesn't take that much to interpret this, right? We're saying that 76% of all people that buy their lunch rode the bus. That's it. All right? Maybe that's interesting, maybe it's not. In the next lesson, we're going to get much more deep into how to interpret all of this. But for now, we're just mostly trying to calculate these. Now, conditional relative frequencies, or what are known as relative proportions, are simply the fraction, the proportion, or the percentage of a subgroup that has a particular characteristic. These can sometimes be a little bit tricky to interpret. So let's take a look at exercise number 6. A restaurant serves 2 types of juice for breakfast, orange and apple. They want to understand how the choice of drink depends on whether the customer is an adult or a child. During one breakfast, they record choices by age with the results shown below. Okay, this is cool. Let's talk about this a little bit. Now, we're going to really get into this a lot more in the next lesson, but the idea here is that we're really trying to understand, does falling into one category mean that you're more likely to then fall into another category or not, right? So here what we've got is we've got, these adults and children that were eating breakfast, and we know that there were 26 adults that chose orange juice, and there were 9 adults that chose apple juice, 28 children chose orange juice, and 19 children chose apple juice. All right, let's take a look at letter A. How many people did the restaurant get data from? Okay, well, pause the video now and see if you can figure out how to do that. Well, what we're asking for in letter A is the grand total. We want literally all these numbers added up. So to do this, we need to just do 28 plus, actually maybe start with 26. I don't know why I started with 28. 26 plus 28 plus 9 plus 19. Of course, it doesn't really matter how you add them up. You just got to get the right total. Let me clear this out. We've got 26 plus 28 plus 9 plus 19, grand total of 82 people. Okay, great. All right, let's keep working with it. Let's take a look at letter B. What proportion of all people surveyed preferred orange juice as their choice? Round to the nearest hundredth. Now, notice, right, proportion and round to the nearest hundredth. Sometimes they'll ask you for the proportion, right, which is the same as a relative frequency, and sometimes they'll ask you for a percentage. Be careful on that. Even though I would love to be able to accept both of the answers as being interchangeable, most of the time your math teacher can't. Anyway, let's take a look. What proportion of all people surveyed preferred orange juice to their choice? Well, we know then that we're working with all people, 82 people. How many people liked orange juice? Well, that was 26 plus 28, so let's figure that out, right? The frequency, 26 plus 28, that's 54. So 54 people is actually the frequency of the people who chose orange juice as their favorite drink. But now I want the proportion, right? So what I'm going to do is I'm going to do 54 divided by 82, and I'm going to round that to the nearest hundredth. So 54 divided by 82, enter, and I get 0.66 rounded to the nearest hundredth. All right, now don't get me wrong, I always encourage people to then look at this and say, oh, that means 66% of all the people that they observed or surveyed or whatever chose orange juice. Of course, you can also say that that means 34% must have chosen apple juice, right? Because those were your only two choices here. Let's take a look at letter C. What proportion of all adults surveyed preferred orange juice as their choice? Round to the nearest hundredth. Now, right, this one now is a conditional relative frequency. All right, but I don't even need to know that term, right? In letter B, they said what proportion of all people. In letter C, what proportion only of adults? It's all I care about at this point. I just want to have the adults. So I'm not worried about the child column anymore. I just want that. Pause the video now and see if you can figure out what proportion of all adults preferred orange juice as their choice. Well, there were a total of 35 adults, right? 26 that liked orange juice, 9 that liked apple juice. So in total, we've got 35 adults. Okay, that's our denominator. And our numerator are going to be the ones who chose orange juice, and that's going to be 26. And so now I can just bring my calculator out again. Maybe clear this up a bit so that it looks a bit better. 26 divided by 35, and we're going to get 0.74 rounded to the nearest hundredth. And again, right, it's simple enough. 74% of all the adults chose orange juice, right? You could then say 26% chose apple juice, but 74% chose orange juice. All right, I've reproduced it right here so that we can see that frequency chart again. Let's take a look at letter D. What is the relative frequency of being an adult in this survey given that the person preferred orange juice? Round to the nearest hundredth. Now this one's a little tricky. Now I want to know really, what percentage of the people, or sorry, what is the relative frequency of people who are adults, what is the relative frequency that you'll be an adult given that the person preferred orange juice, right? Given that the person preferred orange juice. Okay, so play around with this. Pause the video and see what you get. So now we're only talking about the people who prefer orange juice. We're literally now talking about this row versus the columns that we were looking at before. And when we look at this, right, there are 54 total people who prefer orange juice, right? 26 plus 28 is 54, so that's our denominator. What's our numerator? Well, the frequency of being an adult, given that they prefer orange juice. Of those 54, 26 of them are adults. So let's take a look. 26 divided by 54 gives us 0.48. All right, and again, right, thinking terms of percents, 48% of everyone who chose orange juice was an adult. That's actually pretty close to a coin flip, right? 48% of the people who chose orange juice were adults, must mean 52% that chose orange juice were children. Let's take a look at letter E. What is the relative frequency of liking apple juice in this survey, given the person is a child? Round to the nearest hundredth. Okay, great. Pause the video and see if you can get this one. All right, well again, given that the person is a child, right? That means all I care about are these. 28 plus 19 is 47. There are 47 children in total. All right, so that is our denominator. Our numerator is those that like apple juice. So that's 19 out of 47. And let's take a look. 19 divided by 47. And that will be 0.40 rounded to the nearest hundredth. All right, so 40% of all children chose apple juice. Now, side note, that means that 60% of all children must have chosen orange juice. All right, finally, let's take a look at F. Does it seem that there is an association between which juice is preferred and whether the person is an adult or a child? Explain. All right, now what this really means is, does being a child or an adult seem to affect how likely it is that they will choose orange juice or apple juice? That's what it really boils down to, okay? So pause the video now and think about that a bit. And the answer is yes, okay? And we could take a look at a bunch of different things, but let's just consider orange juice for a second, right? Now this is a little bit tricky, but if I come up here, right, what I see here, what proportion of all adults preferred orange juice? 74% of all adults preferred orange juice. Now, we never really calculated the percentage of kids that preferred orange juice, but we can figure it out very quickly. 40% of all kids preferred apple juice. That means 60% of all kids preferred orange juice. So 60% of kids preferred, oops, two R's, preferred orange juice, and therefore it is more likely an adult will pick orange juice than a kid will. That's generally the case. Apple juice is generally much sweeter than orange juice, and kids definitely have more of a sweet palate than a sour palate. Orange juice is more sour than apple juice, all right? Now, had these two been nearly identical percentages, or had they been exactly identical percentages, then we'd say there was no association. Let's say that 74% of adults preferred orange juice and 72% of kids preferred orange juice. Then we'd say, well, then the preference for which juice they're going to choose really has no association with their age. It doesn't matter whether you're old or young. About 3/4 of everyone would prefer orange juice in that situation. But here, there is a notably higher percentage of adults that prefer orange juice than kids who prefer orange juice. And so we say that there is an association between age and juice selection. That sounded funny when it came out of my mouth, but we'll roll with it. All right. So today, we looked at categorical data for the first time in Algebra 1. I know that you've probably seen it in other courses, but for the first time we looked at it in here. And we looked very hard at how to turn frequencies into both relative frequencies by just dividing everything by the total. And again, as I pointed out, those frequencies, always expressed in terms of decimals, often to 2 decimal places, are really just the equivalent, the decimal equivalent to percentages. And you really want to be able to process those in your head because we think well in percentages. Oh, 56% of them liked this, 22% of them liked that, right? It's easy to think about that in terms of percentages as opposed to, well, 0.56 relative frequency liked this. That's strange. And yet you need to kind of know the differences between relative frequencies and percentages, even though to me, they are basically the same thing. We're going to get in our next lesson a lot more work with interpreting whether or not those conditional relative frequencies show us that there's an association or not between the variables. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.